Hello, everyone. While we often take clean water for granted, the world is facing an increasingly complex water crisis. As pollutants like microplastics and industrial chemicals become harder to manage, developing better filtration has become a top priority for scientists. One promising solution is graphene oxide. To understand why, we first have to look at graphene itself, a single layer of carbon atoms in a hexagonal lattice. It's incredibly strong, but standard flat sheets tend to clump together because of molecular attraction. This restacking effectively seals the filter and stops water from moving through it. To get around this, we use onion-like graphene. This involves rolling graphene layers into concentric spheres, much like the layers of an onion. Because spheres can't lay flat against each other, they don't clump. This creates permanent nano-channels that allow water to flow through at very high speeds. Since the surface is atomically smooth, there's almost no friction, which makes these filters much faster than traditional sand or charcoal versions. The real magic happens when we oxidize this structure. By adding oxygen, we introduce functional groups that act as the filter's chemical engine. Carboxyl groups, for example, carry a negative charge that pulls in positively charged pollutants. At the same time, hydroxyl and epoxy groups form strong chemical bonds, like hydrogen bonds, that lock contaminants in place so they aren't washed away by the current. This system is designed to tackle three main challenges. First, it addresses desalination. The biggest problem with seawater is that salt ions attract water molecules, forming a bulky hydration shell. By narrowing the gap between the graphene layers to exactly 0.7 nanometers, we create a molecular sieve. It's wide enough for single water molecules to pass, but too tight for those bulky salt ions. This is much more energy efficient than reverse osmosis, because the water simply glides through instead of being forced through a thick membrane. Second, the material is excellent for organic pollutants like industrial dyes or pesticides. These complex molecules are drawn to the high surface area of the onion-like graphene and are trapped by those functional groups we talked about earlier. Third, it's highly effective for heavy metals like lead and mercury. By modifying the graphene with nitrogen or sulfur, we create binding sites that wrap around metal ions in a process called chelation. Since just 1 gram of onion-like graphene has a surface area covering hundreds of square meters, we can fit millions of these traps into a tiny space. This technology could really change things for global industry. It means desalination plants could produce fresh water cheaper and faster, and factories could treat their own waste before it ever reaches our rivers. Ultimately, by engineering carbon at this level, we're working toward a future where safe water isn't a luxury, but something everyone can access. Thanks for listening. I'm glad to take any questions you have.